Good morning, everyone. So, in previous video, we had done till question number 3. Now we will do question number 4. So, here it says that in figure 8.39 OA, okay, is equal to OB, OC is equal to OD, and angle AOB. That means this angle is equal to angle COD. Okay, so this angle is equal to this angle. What we are supposed to prove? We are supposed to prove AC is equal to BD. That means this AC is equal to BD. Okay, we have to prove this. Now you can see this AC is part of this triangle AOC, and BD is part of this triangle BOD. So we will try to show that triangle AOC is congruent to triangle DOB. Okay, and once we have proved this, then by corresponding parts of congruent triangles, we can say that AC is equal to BD. So let us see the solution. Solution. Given OA is equal to OB, OC is equal to OD, and angle AOB is equal to angle COD. Now this angle AOB is equal to angle COD can be written like this. This angle AOB can be written as sum of this angle and this angle. Yes, so I can write angle AOC plus angle COB, and angle COD, okay, angle COD can be written as this COD can be written as sum of this and this. So we can write angle COB plus angle BOD. So here what do you observe is that this is common. Okay, this is common. So here angle COB, okay, and here also angle COB. So these two will get cancelled, and you are left with angle AOC is equal to angle BOD. Okay. Now we'll try to show that these two triangles are congruent. Now in triangle AOC and triangle DOB, first of all OA is equal to OB. Okay, this side is equal to OB, so I can write number 1 OA is equal to OB, and this is given to us. Next we can write OC is equal to OD. OC is equal to OD. This is also given. And thirdly, we can write angle AOB is equal to angle COD. Okay, since angle AOB is equal to angle COD. So here what do we observe? That side and this side, this side and this side and this angle. Okay, so side angle side, side angle side. So these two triangles are congruent by side angle side axiom. Okay, therefore triangle AOC is congruent to triangle DOB by side angle side axiom. Okay, now since these two triangles are congruent, therefore their corresponding parts, okay, are going to be congruent. Okay, that means corresponding angles equal, corresponding sides equal. So corresponding side for AC is BD. Okay, therefore these two will be equal. Thus AC is equal to BD since congruent part of congruent triangles are congruent parts of corresponding parts are of congruent triangles, CPCT. So this is proved. Okay. Now let us see question number 5. In figure 8.40, okay, prove that triangles OAM, OAM and OBN are congruent. That means these two triangles are congruent. We have to show that. Okay, and hence prove. And after that we have to prove that AM, this distance will be equal to BN. Okay, once we have shown that these two are congruent, then corresponding parts of congruent triangles are going to be equal. Okay, so solution: given here in figure, if you see AO and this cut is there, and here you see OB and this cut is there, that means AO is equal to OB. So we'll write given AO is equal to OB, and okay, since we have to show that these two triangles are congruent, so let us write like this: in triangle OAM and triangle OBN, number 1, AO is equal to OB, given to us, you can see in the figure. Number 2, angle AOM is equal to angle BON, vertically opposite angles. Okay, this and this vertically opposite, so equal. Number 3, angle AMO is equal to angle BNO equal to 90 degree. This is also given. So these two triangles are going to be congruent by angle side. Okay, therefore triangle OAM is congruent to triangle OBN by angle side axiom. Thus AM is equal to BN. Like here you can see we have proved that these two are congruent. Okay, where A corresponding to AO is OB, corresponding to OM, here we have ON, therefore corresponding to AM we'll have BN. Okay, so corresponding part of congruent triangles are equal, so AM will be equal to BN since CPCT corresponding part of congruent triangles. Okay, so this question is done. Okay, now let us see the next question, question number 6. In figure 8.41, angle XYZ, okay, this whole angle is bisected by YP. So this YP is bisecting this whole angle. Let's say this whole angle is 60, then this will be 30 and this will be also 30. Okay, then L is any point in YP and MLN is perpendicular to YP. So this is 90 degree, okay, and this is a straight line, so obviously this will be also 90 degree. Done. We have to prove that this LM will be equal to LN. Okay, so in order to show that, we have to show that this triangle is congruent to this triangle. Okay, so solution: in triangle YLN and triangle YLM, number 1, YL is equal to YL. Here we have got two triangles and this YL is common for both the triangles. Yes or no? So that's why I wrote YL is equal to YL, common side. Okay. Number 2, they have said that this whole angle is getting bisected by this line YP. That means this angle will be equal to this angle. Clear? So I can write angle MYL is equal to angle NYL, since YP bisects angle XYZ. Because this line YP is bisecting this whole angle, that's why here these two will be equal. Number 3, angle MLY is equal to angle NLY equal to 90 degree. Reason is this MLN is perpendicular. Okay, since MLN is perpendicular, in short I'm writing PLN. ERP dot perpendicular to YP. Okay. So here you here you saw that angle, side, angle. Okay. This angle equal to this angle. This side is common for both. Here 90, so here 90. So angle, side, angle. So these two triangles are going to be congruent by angle, side, angle axiom. Okay. So we will write, therefore, triangles YLN is congruent to triangle YLM by angle, side, angle axiom. Okay. And what we are supposed to prove? At the end we have to show that LM is equal to LN. So you can see that LM is part of this triangle, okay, and LN is part of this triangle. Since we have shown these two congruent, so corresponding parts are going to be equal. Thus, LM is equal to LN since corresponding parts of congruent triangles, because they are corresponding parts of congruent triangles, so they are going to be equal. Okay. Okay, now let us see question number 7. In figure 8.42, x is any point within a square ABCD. So ABCD is a square. That means AB equal to BC equal to CD equal to AD. X is any point within this square. Next, on AX, so this on AX, a square AXY Z is described. So we have got one more square, that is AXYZ. That means this side AX will be equal to, you know that sides of square is equal. So since AXYZ is a square, so all sides are going to be equal. So that's why I have put two lines, okay, to just to denote that they are equal. Okay, these sides are equal, and single line for this ABCD one, these are equal. Okay, what we are supposed to prove, Bx equal to dz. So you can see your bx is here and dz is here. Okay, so if we could show that this triangle, okay, this triangle is congruent to this triangle, if we could show this, then we can easily prove that bx is equal to dz. Okay, so let us do that. And one more thing over here, since ABCD is a square, so angle, these angles are going to be 90. Okay, these angles are going to be 90. So here this will be 90. Now same goes for this square also. AXYZ, this will be 90. Okay, but here you can see that this angle is common. Okay, this angle is common for both. Clear? Therefore this angle and this angle, these are going to be equal. Okay, so let us see. in triangle ADZ and triangle ABX. Number 1, this angle, okay, will be equal to this angle. Angle ZAD is equal to angle BAX. Since this DAX is common, angle DAX is common. Okay. Number 2, here you can see that AD is equal to AB, because AD and AB, these two are sides of same square. So AD is equal to AB, sides of ABCD. And third, AZ and AX equal. AZ is equal to AX. Reason is sides of AXYZ. So here we saw that side angle side, side angle side. Okay. So this side, this side, this angle, this angle, this side, this side. So by side angle side, these two triangles are congruent. Therefore, triangle ADZ congruent to triangle ABX by side angle side axiom. Okay. Hence, BX equal to DZ. Here you can see that corresponding to AZ you have AX, corresponding to AD you have AB, therefore corresponding to DZ you will have BX. So reason is corresponding parts of congruent triangles are equal. Okay, so this is proved. Okay children, now let us see the next question, question number 8. In figure 8.43, prove that AP bisects angle BAC. Let's say this total is 100 degree. Okay, so they want you to prove that if you join this A and P, then this angle should become 50 and this also 50. Okay, so they want you to prove that this line AP bisects this whole of this angle. Okay, so we have to prove that. So how we can prove that? We can prove it by showing this triangle congruent to this triangle. Once we have shown this triangle is congruent to this, then we can say that this angle equal to this angle equal to this, and this equal to this. So once we show that these two are equal, therefore this AP is the bisector of this angle. Okay, so let us see. Solution. Join AP with dotted lines. Okay. Now in triangle ANP and triangle AMP. Number one, your angle ANP is equal to angle AMP, that is 90 degree given. Okay, so this is done, and here you can see that these two triangles are right angle triangle. So the side opposite to the right angle is called hypotenuse. Okay, so here hypotenuse for this one is AP, and hypotenuse for this triangle is also AP. So here hypotenuse is common. Okay, so number 2, AP equal to AP, common. Hypotenuse. Okay, then thirdly, PN is equal to PM given to us. Okay, so there was one axiom which says RHS, right angle, hypotenuse and one side. Okay, so here you can see right angle, right angle, hypotenuse common for both, then one side. Clear? So triangle ANP is congruent to triangle AMP by RHS axiom. Clear? So these two are congruent. So here you can see that NP is corresponding to PM and AP, AM and this AN corresponding. Same way, corresponding angle to this is this 90, corresponding to this is this, therefore corresponding to this one will be this angle. Okay, so you know that corresponding parts of congruent triangles equal, so therefore this angle and this angle equal. So hence angle MAP is equal to angle NAP, since corresponding parts of congruent triangles. And once these two angles equal, that means this line is bisecting the whole angle. Okay, therefore AP is bisector of angle here NA. Once again, let me see in the question what they have written. BSC. So angle BAC. Okay, proved. So this is all for today.